In this video, we're going to continue finding areas between two curves, and you should have watched the two videos on finding area before watching this one. There's an introduction and then another video on setting up integrals, so go back and watch them if you have not already done so. Let's look at these problems, and if you have these, great, you can look on with your handout. If you don't, you can read the video and pause as necessary. But I want you to also use your graphing calculator to look at the graphs of these problems as we go. So for the first problem, we want to find the area of the region bounded above by the graph y equals e to the x. So put that in your calculator, and below by the graph y equals x. So put that in your calculator as well. And we want the area bounded on the sides by x equals 0 and x equals 1. So if we graph this in our graphing calculator, I'm just going to sketch a picture of what you get. Y equals e to the x goes through the point 0, 1, and it's an exponential growth, so it's going to roughly look like this. Okay, and then y equals x is a linear graph that roughly looks like this, and we're looking at the area from x equals 0, which is a vertical line here, to x equals 1. And this is just a rough sketch, but you should have something similar in your graphing calculator, depending on what the window is that you're looking at. So we want to find the area of this region. Now, I'm drawing vertical lines. I think the easiest way to do this is to go in the x direction, to go from 0 to 1. So we're going to do an integral from 0 to 1, and we're going in the dx direction because we're going from left to right. And we want to make sure that each of these strips is a length, which is the top curve, subtracting the bottom curve. And our top curve is y equals e to the x, and our bottom curve is y equals x. So if we want to get the length of each strip, the length of each strip is going to be e to the x minus x. And this is pretty reasonable to integrate. Let me move this over a little bit. If we integrate this, the integral of e to the x is e to the x. The integral of x is x squared divided by 2, and we are evaluating this from 0 to 1. So first we're going to plug in 1. So we get e to the first power minus 1 squared over 2. Then we're going to plug in 0. So we get e to the 0 minus 0 squared over 2. And this, of course, disappears. This turns into 1. So we have a minus 1 here. This is a negative 1/2, and this is e. So we get e minus 1/2 minus 1, which is the same as e minus 3/2. So this is the value of our integral. This is the actual area. So if you want to put a label on it, you could say units squared. You could also get a decimal approximation if you wanted to. All right, so there's an actual problem with a numerical answer that we arrived at the end. Let's go on to problem number 2, and let's find the area of the region enclosed by the parabolas y equals x squared and y equals 2x minus x squared. Again, go ahead and put these both into your calculator and do a sketch roughly of what they look like. And when you do your sketch, you get this area enclosed by the two curves here. And again, I'm going to do vertical lines because it is easy to do it that way. We have a point of intersection here and a point of intersection here. So we need to know, if we're going to go in the x direction, what the x values are for these points of intersection. So I need to do a little bit of work to figure those out. But the top curve is this green curve, which is represented by 2x minus x squared. And our bottom curve is the x squared. So we're going to subtract the bottom curve, and we're going in the x direction, but we still need these limits of integration. So we need to figure out what our intersection points are here, and we want the x values. So we're going to set these two curves equal to each other. X squared equals 2x minus x squared. If we add the x squared to both sides, we get 2x squared equals 2x. Which means x squared equals x. If we get this on the other side and factor, x squared minus x equals 0, we can say that our zeros are going to be x equals 0 for this factor and x equals 1 for this factor. So we're going to integrate from x equals 0 to x equals 1, and those are our limits of integration. And this actually simplifies. Let's simplify this before we integrate. 2x minus 2x squared, and that's what we're going to integrate. So when we integrate that, we get x squared minus 2x cubed divided by 3, evaluated from 0 to 1. So when we plug 1 in, we're going to get 1 squared minus 2/3 1 cubed minus, and now we plug in 0. 0 squared minus 2/3 times 0 cubed. And this whole quantity turns into 0. So what we end up with over here is 1 minus 2/3, which equals 1/3. So the area enclosed by these two curves right here is 1/3 units squared. I want you to skip ahead to problem number 7 in your handout if you have it. In this problem, if you look at the two functions that you're given, they are given in x equals form. And these are a little bit harder to graph on your calculator. You have to use parametric mode, and for those of you that have the handout, there are instructions on how to do that on the handout. You can also use an online grapher, and my favorite is Desmos. So I've already graphed these in Desmos. If you look over here, you just type in the equations as you see them, and what happens is you get a nice graph. And the nice thing about Desmos is it also gives us our point of intersection here, and it highlights them for us, so we know exactly the 2 points of intersection. If you look at these two graphs, there's clearly a region that is enclosed by the intersection of the two graphs. If we look at this region, it's probably going to be easiest to integrate with respect to y. So we want to start at where y equals -1, and we're going to go up to where y equals 1, and we're going to integrate the right curve minus the left curve. And the right curve is the quartic, so it's this 1 minus y to the 4th. And our left curve is this top curve, y cubed minus y. So I'm going to sketch this on my paper. We're going to go through the integral. Why don't you take a moment to do that as well, and we will regroup and do the integral. Alright, I have my graph sketched and my integral set up. Make sure you put parentheses around the second function because you're subtracting the entire quantity, so you need to remember to distribute that negative sign. So I'm going to go ahead and do that and add the opposite, and then I'm going to simplify and integrate. And there's really not much here to simplify, so I can just go ahead and integrate. When I integrate, I get y minus y to the 5th divided by 5 minus y to the 4th divided by 4 plus y squared divided by 2, and we're integrating from -1 to 1. So go ahead, evaluate that right now, see what you get, and we'll compare our answers. The solution I ended up with is 8/5, and you just have to be really careful with your arithmetic here. You can do it by hand, and you can check with your calculator. So now we've gone through integrals going in the x direction, going in the y direction. You have several more problems to do in the handout if you have one, so work on that with your group. The answer key is with the teacher, so check your answers, work together, and I will be there this afternoon. Have a great day. See you guys later.